Hi, good morning my dear students, and how are you? What about your studies? Is it going well? Okay, so in the last class I have given you some problems that relating the equation of mirror formula or magnification, like that. Okay, so hope you all done that and you should submit your notes. Okay, so we have to discuss a new topic today. That means what is your chapter's name? Yeah, light, reflection and refraction, right? So till now we have completed the first part, reflection, that is reflection of light. Okay, so today we have to study the second part, that is refraction of light. So now we are going to study what? Refraction of light. Okay, so you all know, or we know, light travels or light seems to travel in a straight line through a transparent medium, right? And this is known as the rectilinear propagation of light. So what happens when light enters from one medium to another? That is, light travels from one transparent medium to another transparent medium. Does it still move through straight line? Yeah, some changes may be happened there, right? So that change, or there may be a change in direction of light when it travels from one medium to another. So this phenomenon is known as what? Refraction of light. Okay, so what is meant by refraction of light? Simply we can say it is the bending of light when it travels from one transparent medium to another. Okay, so we can understand it by seeing some day-to-day experiences in our life. Okay, so it is given that there are some examples given in your textbooks. That is, you might have observed that the bottom of a tank or pond is containing water appear to be raised. It is somewhat raised than actually, right? So this is because of refraction of light. That is, when we see the water in a pond, on a pond, that will appear somewhat above. Means when we see this, the light travels from one medium, means one medium is air, and then it comes to water. So in the interface of this air and water, there is a bending of light. So because of this bending, we can see the water is somewhat raised. So this is because of what? Refraction of light. And some more examples are given here. That is, when a thick glass slab is placed over some printed matter, the letters appears to be raised. These all situations you may experience, right? So another example is given. Have you seen a pencil partially immersed in a water in a glass tumbler? You may see that, or you may experience this in your life sometimes, right? So what happens when a glass filled with water and a pencil is immersed in that? The pencil in the water, that means the part of pencil that immersed in water is look like somewhat bent. Okay, so this is also because of what? Refraction of light. Okay, so that is refraction of light, and there are some more examples in our day-to-day life that is due to refraction, right? So we can see what is the definition of refraction of light. So what we can say? The change in direction of light when it travels obliquely from one medium to another. That means obliquely means that is inclined in some angle, right? That is the change in what is refraction? We can say the change in direction of light when it travels obliquely from one medium to another medium, or one transparent medium to another transparent medium. Okay. So suppose we have this is air, we have the medium air. So obliquely the light travels from air to, here it is water. Okay, you can see, suppose this is a medium that is filled with water, this is or air, right? So light travels from here, and when it travels from air to water, this is water, right? So this is the interface of these two mediums, right? So when it travels from here to here, this is the straight line motion. So it's not going like that, so it may be some bending. Okay, so it may be going like this, or somewhat some bending is happened in this incident light. So this is incident light ray, incident ray. Okay, this is refracted ray. Okay, so this is happened in refraction, that is light travels from air to water, and there may be some bending happens, or there may be some change in direction of light. Okay, so that is what refraction of light. Here it is given, some more examples are given, or the example of our pencil immersed in water, it is explained here. That is the light reaching from the portion of the pencil inside water seems to come from a different direction. That is, the bending of light happens when it travels from air to water. So here it is said that the pencil inside water seems to come from different direction and compared to the part above the water, right? And this makes the pencil appear to be displaced at the interface. Okay, for similar reason the letters appear to be raised, that is the letters below the glass slab, right? That is, when we viewed through the glass slab, the letters become somewhat raised, right? So this is also due to refraction of light. So this is what is refraction, and here it is given some more activities, and also these activities all give the refraction of light, or we can experience through these activities what is refraction. Okay, so you can do this all simple activities, activity 10.7, 10.8, 10.9, you can do it in your homes, right? So we can directly enter into the refraction through a rectangular glass slab. Okay, so we can see how the refraction happen in a rectangular glass slab. So it is also given through an activity. We can understand it through doing an activity. So activity 10.10, look into that. What it says: fix a sheet of white paper on a drawing board using drawing pins. So there is no drawing sheets or drawing pins are along with me, and so I can use this board as a white paper. Suppose it is placed on a drawing board. So what happens, or what we have to do next? Place a rectangular glass slab over the sheet in the middle. So we have to place, suppose this is a white sheet placed on a drawing board, and we have to place a rectangular glass slab in the middle of this sheet. So there is no glass slab and there is no white paper or drawing board, so I can use this. And if you have these kind of things, you can do this activity and you can experience what is refraction or how it happens, right? So we can discuss how it happens. So suppose this is A, B, C, D, right? And draw the outline of the slab with a pencil. So we have already drawn the outline of the glass slab. And take 4 identical pins. If you have pins, you can take some or 4 identical pins and fix 2 pins, say E and F, virtually or vertically, such that the line joining the pins is incident on the edge AB. So you can do this activity. So now we have to look the refraction through a rectangular glass slab. So it is also given the activity 10.10 that shows how refraction happens through a rectangular glass slab. You can do this activity by your own. That is, now you just look into that activity. What the activity says: fix a sheet of white paper on a drawing board using drawing pins and place a rectangular glass slab over the sheet in the middle and draw outline of the slab with a pencil. Let us name the outline as ABCD and take 4 identical pins. Fix 2 pins, say E and F, vertically such that the line joining the pins is inclined at the edge AB. And then look the image of E and F through the opposite edge CD and fix 2 pins, say G and H, such that the pins and the image of E and F lie on a straight line, and remove the pins and the slab. Join the position of tips of the E and F and produce the line up to AB. Let EF meet at AB at O. Similarly, join positions of G and H and it meets at the edge or at edge CD O dash, and let GH meet at O dash, right? And join O dash, also produce EF up to where? Up to P, also shown by dotted line. That is, thus this image is shown, but this image I already drawn here, right? So because I have no sheet of white paper and no drawing board and no glass slab with me, so again explain how happens here by using this figure. Okay, so here it is given that what in this activity you will note the light ray has changed its direction at points O dash. So look into here. That is, this is the points E and F. At first we have to fix 2 pins, say E and F, right? So this is the point E and F, and we join this line into this edge AB at O. It means at O, right? So this is the incident ray. Okay, this is the incident ray, and if it travels, this means the air, this is the medium air and this is the medium glass. Okay, this is glass slab. So this is air and this is glass. So when light travels from air to glass, it bends somewhat here, right? So this is the what? Refracted ray. Okay, refracted ray. That is O dash is the refracted ray, and suppose this is EO. EO is the incident ray. And here At O dash, the light ray again changes its direction, right? That means from glass to air, it also changes its direction. That means this OG is the what? Emergent ray. Okay. This is the emergent ray. This ray. Okay. This ray. This is the emergent ray. So, what are the things that are given here? Note that the both the points O dash lie on the surface. That is this is the interface of these two media, right? That is air and glass. So at the interface of these two media, light ray changes its direction. And here also this is the interface. CD is the interface of these glass and air. Okay. So here also the light changes its direction. Then what are the things we have to do? Then draw a perpendicular n dash to n dash to AB. That is, this is the normal that we have already drawn here, and also here m dash is another normal to CD, right? So this angle is the angle of incidence, the first angle of incidence I1. Okay, and what is the angle of refraction? This is the angle of refraction, R1. And here also from what? Glass to air, there is also change in direction occurs. So we can see this angle is I2, that is incident angle 2, second incident angle 2. And here the second refracted angle R2. Okay, so we have to note that in the figure. And then it says that when the light travels from a rarer medium to denser medium, it bends towards the normal. That means this is the normal, right? And the light ray bends towards the normal. Actually, if it travels through a straight line, it has to take this direction, right? The light ray has to take this direction. But here it travels from a rarer medium to a denser medium. That is, air is a rarer medium and glass is a denser medium. We have to know what is rarer medium or what is a denser medium, or what is the optical density, or what is refractive index. In terms of refractive index, we can see what is the rarer medium, or which one of these is rarer and denser. That all things we have to know. So that we will discuss later. Okay. You just know air is rarer than glass. That is, air is a rarer medium and glass is denser medium. And while going through or while traveling from a rarer medium, that is, air is a rarer medium and glass is a denser medium. That is, from rarer medium to denser medium, the light ray bends towards the normal. Okay, and from glass to air, that is here, this ray, the emergent ray, what happens to the emergent ray? This is the normal and it goes away from the normal. That is, from when light travels from a denser medium to a rarer medium, the light ray travels away from the normal. Okay, so these are the things given here. And one more thing you can see here, that is, the ray, the emergent ray should be parallel to the incident ray. That means here the angle I, that is the incident angle, and here it is the normal, and here also it's the normal. So this angle R1 and this angle what? I2. These are two what? Interior alternate angles, right? This angle and this angle are two interior alternate angles. So this will be equal. That is, R1 angle R1 is equal to angle I2. Okay, and also we can see this I1 is equal to this R2. That is R2 is equal to angle I1. So, what we can see from this? That means this emergent ray and this incident ray are parallel to each other. This is because the angle of refraction, this angle of refraction is equal to this angle of incidence. That means second angle of incidence. And the first angle of incidence is equal to what? The second angle of refraction. That means the bending of light, the extent of bending of light. That is, here it is bent up to this and here it is bent up to this, right? So, this bending of light is what? Extent of bending are similar in both these cases, that from rarer to denser, also denser to rarer. Only difference is from rarer to denser it moves towards the normal. That is, that extent is also same, that the ray from denser to rarer it moves away from the normal. That is, this extent of motion or the extent of bending, we can say the extent of bending is similar in both cases. So that the incident ray and the emergent rays are parallel to each other. Okay. So, that is another thing we can get from this figure, or we can get from the refraction through a rectangular glass slab. So, these are the things given here. So, from this experiment or from this activity we can conclude or we can obtain some laws. That is, the refraction follows some law. Similarly, some laws are there in reflection. That is, reflection of light occurs according to some rules or some laws. Okay, that is law of reflection. Laws of reflection. There are two laws, right? And also, similar to that, refraction also follows certain laws. Okay. So, refraction of light occurs through or according to certain rules. That is, there are two rules or two laws. First law, what is first law? So, hope you understand what happens when refraction through a glass slab. What happens? The light ray enters from air to glass and from glass to air. So, this conclusion or the results obtained from this experiment we can use to make the laws of refraction. Okay. So, one more thing you have to know how the refraction happens or what is the cause of refraction. What is the cause of refraction? Can you say what is the cause of refraction? That is, cause of refraction we can say the change in velocity or change in speed of light in different media. That is the cause of refraction. That is, why refraction happens means we can see the change in speed of light causes the light to be bent. Okay, that means light has different speeds in rarer medium and in denser medium. In rarer medium, light can move more faster when compared to denser medium. That all things we have to discuss in the under the topic refractive index. That means rarer and denser medium we can say by the help of refractive index. So, just know why the refraction happens or the cause of refraction is what? The change in speed or the refraction is due to the change in speed of light as it enters from one transparent medium to another. So, you can underline this, that is in page number 173, the cause of refraction. That means the refraction is due to change in speed of light as it travels or as it enters from one transparent medium to another. Okay. So, we have to know or we have to discuss what are the laws of refraction, that we can discuss in the later or next class. Okay, so hope you understand what happens the refraction through a rectangular glass slab. Hope you can do that in your by your own in your homes. Okay, so try to do that and try to experience the refraction of light through glass slab. Okay, so let me conclude. Hope you understand this well. So there is one more thing you have to know, this distance what we can see, the distance is some distance, this emergent ray and the actual incident ray, if it travels or if it travels through a straight line, this shift is known as what? Lateral shift. That is, what is the lateral shift? Says the emergent ray shifts laterally from the actual incident ray due to the phenomenon of refraction. So this difference between incident ray and the emergent ray is known as lateral shift. Lateral shift. Okay. So what is lateral shift? This is the what? The emergent. I can write it is the emergent ray shifts laterally from the emergent ray shifts laterally from the actual incident ray. Due to what? Refraction. This is known as what? Lateral shift. So here refraction happens in this case, that means from rarer to denser, also denser to rarer, and this shift is known as lateral shift. And these are the things that gives by refraction through rectangular glass slab. So read this activity and the explanation given under this activity, and if you have any doubt you can ask me and I will clear that. And what we can meet in the next class and we can discuss the laws of refraction, also the refractive index, that all things we can discuss in the next class. Okay, so till then take care and please try to do this activity and try to write this in your notebook. Okay, so let me conclude and see you tomorrow or see you in the next class. Okay, till then goodbye and thank you.